Hi, my name is Anastasia, and I'm here to talk to you about Ethereum. So it's likely that many of you have heard of the terms blockchain, Bitcoin, Ethereum over the past 6 months. Cryptocurrencies have gotten a lot of attention, but some people are a bit confused. I think we should build a blockchain. Uh-oh, does he understand what he said, or is it something he saw in a magazine ad? What color do you want that blockchain? I think mauve has the most RAM. Blockchains don't have RAM. Blockchains don't come in different colors. But jokes aside, Ethereum is an incredibly powerful computational ecosystem. It may not replace the way we do computing entirely, but it does provide opportunities to do computing that weren't possible before. To start us off, I'm going to give a bit of background on distributed ledgers, which are also known as the blockchain. And understanding this is crucial to understanding the Ethereum ecosystem. So distributed ledgers are like a big list that everyone shares. And since everyone shares it, when you add something to the blockchain, everyone knows about it. This makes for computing that's immune to censorship, immune to collusion, counterparty risk, and in the context of currency, it means that your wealth doesn't actually rely on the government or on central banks. The most famous of these distributed ledgers is called Bitcoin, which Dinah previously mentioned. It's a digital asset or a digital money, and it involves transactions like sending money from Alice to Bob. And the first block of Bitcoin that was mined had the message, "Chancellor on the brink of second bailout for banks" on January 3rd, 2009, which was probably sort of a hit at the current system and showing some disapproval and also proof that it was mined at this time. And so each additional block gets added to the list by miners who confirm every transaction that takes place. By laying the foundation with Bitcoin, we can move on to understanding Ethereum. Many people know of Ethereum as a currency, but really that's just the tip of the surface, or the tip of the iceberg. Ethereum is an entire ecosystem. There's an Ethereum virtual machine, which runs smart contracts in an isolated sandboxed way. It supports distributed applications and tokens, and so we'll look at each of these soon. I find that to understand Ethereum, it's often helpful to compare it to Bitcoin. So they're similar in that they both rely on the blockchain, so distributed ledgers. But Ethereum's key technology is smart contracts. It lets you run programs on the blockchain and lets you make conditional transactions. So in this case, you can send money from Alice to Bob if the date is January 1st, 2008, and if Bob's balance is less than 10 ETH. In a nutshell, smart contracts are the heart of what makes Ethereum different and so powerful. It's a contract between two people that's written into the blockchain. It runs as a program or a script. It's written in a language called Solidity, which is very similar to JavaScript. And you pay Ether to incentivize someone to run this code, which is also known as paying for gas. So when you're buying Ether, what you're really buying is the ability to run code in this ecosystem. One of the recent projects on the Ethereum network is called CryptoKitties, a game that lets you mate and trade virtual cats. And it runs a decentralized application on the Ethereum virtual machine. So to understand how smart contracts work, we can consider this one. Since it's published on the blockchain, anyone can read and verify it. And so this is a small excerpt. After two cats mate, a new kitten is created. And in this arrangement, in CryptoKitties, the mother gets to keep the kitten, whereas the father gets some amount for the transaction, or for this interaction, which you can see in the message, send auto birth fee. But in the end, the mother can then sell the new kitten, or mate it, or sire, and so on and so forth. So both of the parties, in this case, profit. And lastly, the contract returns the new kitten's ID. So this smart contract is a classic example of specific responsibility and conditionally transferring money. If you look in their interface, you can also see how it happens. If we click OK, buy this kitty, what comes up is the MetaMask wallet, where you can see the amount that you're paying for this cat, which in this case is $5 US. You can also see the maximum transaction fee, so how much you're paying to have this transaction processed on the network. And this comes out to a total of 547 USD. And then you can submit or reject this transaction from actually happening. So I didn't end up buying this cat, but it's OK. With Ethereum transactions, you pay a fee for your transaction to get included in the next block, as I mentioned. And the people who run these smart contracts and build the next block of the shared list, they're called miners. Once the transaction succeeds, we can see a lot of information about it on a service called Etherscan. So this was for another transaction that I did, which was breeding two cats together. And you can see at the top that this transaction succeeded. You can see that the contract that was executed in the from line. You can see how much I paid to execute this contract, which was 16 cents, and the function that was run. So this is sort of like a receipt for one of my transactions. This brings us to Ethereum decentralized applications. So a set of smart contracts, they constitute a decentralized application. And it's owned by a group of people, not an individual, since everyone has a stake of this shared list. And within decentralized applications, you have two types of tokens. So there's usage tokens, which can act like a currency inside the application. And there's also work tokens that make you a shareholder of the decentralized application. So you can vote on what decisions and what changes get made. Knowing what we've covered so far, we can explore some existing projects in this space. So there is IPFS, which is a decentralized app for file hosting where no files can be deleted. There is Augur, which is a decentralized application for predicting events. There's Leroy, which is a social media platform sort of similar to Twitter. There's Basic Attention Token, which allows you to make microtransactions for the content that you consume online instead of being targeted by ads. So these are just a few of the technologies that exist. There's many more that are currently in development. But similar to creating a web or a mobile application, there is a substantial decentralized application requires a few things that common web applications do. This includes computing, file storage, external data, monetization, and payments. And you can see that some of these components already exist in the Ethereum ecosystem, and all of them obviously exist in our current web system. But some of the other ones are still in progress. But I expect that probably by the end of 2018, most of these components will be in place, and it'll be much easier to develop applications in this space. And so, although my previous Ethereum example was about a cat game, I want to give a more impactful example before we talk about the future. So I previously mentioned IPFS, which also stands for Interplanetary File System. And it works by connecting all computing devices with the same set of files through a system of nodes. And so in most cases, the internet works great, but it doesn't work so well if you're being censored by the government. This was the case in Catalonia. And Catalonia is one of Spain's autonomous communities that had many pro-independent movements over the past few years. It has a very heated political climate, and many Catalonians have been pushing for independence from Spain. So long story short, Catalonia ended up unilaterally organizing a referendum on its independence, which was to be held on October 1st. But the vote was declared illegal by Spain's courts. And so one of the things that they did to try and stop the vote was to block all the websites that supported it. This included national police forces that raided internet service providers. It included seizing control of websites that offered information about the referendum, and also persecuting people who owned those sites. People are usually told where to vote through official postal mail that arrives at your doorstep. But in this case, the official postal carrier, Correos, I'm going to butcher this, is completely state-controlled. So as soon as they got any information about this particular referendum, they would seize control of it. So that led to the question, how are people supposed to know where to vote? Catalonia's solution was to use IPFS to use their site informing people about where to vote. So this is the site that they hosted. Doing this had a few benefits. It meant that the domain owner wasn't related to the independentist cause that Catalonia was behind. And so it made it harder to justify legal action against their particular domain and harder to take their site down. On top of that, IPFS.io is just a proxy to the IPFS P2P distributed content address file system. It's a mouthful. But that means that if you download the IPFS client, you get instant access to all the content that's stored there. So as you can see, the uses of Ethereum, they range from like somewhat comical to having pretty serious impacts on people's lives. Somewhere between the two is where the majority of future decentralized applications might lie in this ecosystem. But before we get there, Ethereum right now isn't without its challenges. There's three major challenges that I'm going to talk about. They are scaling, irreversibility, and documentation. So first we can look at scaling. Having every Ethereum node that store all the data that exists and store every change to the ecosystem is really hard. People are exploring some solutions such as sharding, off-chain transactions, but to give you a sense of the problem, the scale of the problem, Ethereum can currently handle 13 transactions per second, whereas Visa currently handles 45,000 transactions a second. So we still have a long way to go, like many orders of magnitude to go before we can actually create applications that respond in a similar way that we're used to right now. And this is sort of the cost that we pay, or the price that we pay for being sort of censorship immune. So clearly there's a lot of work to be done. Fred Eschram wrote a Medium post about this called Scaling Ethereum to Billions of Users, and he highlights that he highlights the efforts that a lot of people are working on to make improvements in this space. But as you can see in the status column, that a lot of these are still proof of concept, or some of these are waiting on other technology to be implemented. Few of them have actually gone into production. A lot of the code is still in progress. So there is a ton of work still being done in progress here. But these are hard computer science and game theory problems, and most of them haven't been solved before. And so one thing to also note from this table is that these projects have very few people working on them. Most of them have less than 5. And so the people currently working on them, they're exceptionally talented, like not to talk down on them at all, but nonetheless, they do need more help, and they do need more people that are involved in these problems. So another challenge or maybe feature of the Ethereum ecosystem is that you can't undo anything. So what gets committed to the blockchain is irreversible. And though this is intended in the implementation, especially to prevent censorship, it does bring its own complications. So for example, in 2016, there was a project called the DAO, the Decentralized Autonomous Organization, that was hacked when the users found a vulnerability in their code, and it allowed the attacker to take about 1/3 of the DAO's funds into their own account. The only way to undo this hack was to make a copy of the state of the system before the hack had occurred and fork the entire Ethereum ecosystem. So this was what people chose to do. And what you know of as Ethereum is the forked version of the consequence of these events. The old chain is referred to as Ethereum Classic. And this was a very controversial decision because it's sort of like rewriting history. But what this hack, along with a similar hack with the Parity wallet, shows us is that the cost of writing bugs and getting hacked has never been more apparent. The amount of money that is at stake in these cases is often many millions of dollars. This will continue to get more complicated in the future because there's currently very little regulation or laws in this space. So far, the conflicts that arise are resolved by some consensus of the community, but this doesn't necessarily mean that the resolutions are the most optimal or the most moral decision. And this becomes an even bigger problem in a largely homogeneous environment, which the cryptocurrency space currently is. The last major challenge with the current Ethereum ecosystem is that it's limited in documentation. If we're trying to push a lot of people to, or we're trying to introduce a lot of people to this ecosystem, there is often not enough documentation to support it. A lot of it is uncharted territory, and a lot of it is problems that people have never solved before. Of course, this is a direct byproduct of the space changing so rapidly. So if I were to initially have written this talk 6 months ago when I was first accepted to Starcon, a lot of what I would have said would be already out of date and deprecated by now. So most of the developers in the space are highly conscious of the problem, and the ones that are the ones that see their technology adopted the most widely. And so they become the most successful. So hopefully, in 2018, there's a lot of progress made in this space, and it's not as big of a problem as it currently is. Ethereum may not be the be-all, end-all of decentralized computing, but it's a really cool step in the direction of progress. And with that, we can explore what would happen if it really were to take off. Your future world with Ethereum might look something like this. You wake up and you're still in bed, you browse some news on the distributed news network, a network that delivers news to you from all around the world that can never be censored or taken down. It'll show you news from places that your current news networks don't usually surface, including events in the Philippines, coverage from top tech companies in India, and employment change in Estonia. You'll get out of bed and you'll sip some coffee from a family farm in Estonia. Many coffee growers that previously experienced unreliable income will have a steady stream of drinkers by rewarding superior quality harvests and giving money directly back to the farmer without middle people. So what will happen is each harvest of coffee will be put through a special machine that generates a token that uniquely ties to this batch of coffee, letting you know exactly where it came from and giving money directly to the farmer at the time of the purchase. You'll continue browsing the internet, but instead of being targeted by Facebook's ads or whoever's ads that you see so frequently on the internet, you'll pay a small amount, a microtransaction, for using those sites' services. This is also how you'll compensate your favorite music or YouTube artists. If it's the weekend, you might choose to internet call your friends who are currently traveling the world, maybe even in China, without worrying about firewalls or restrictions. If it's the first of the month, your rent might be automatically transferred from your landlord to buy a smart contract. Or perhaps you're considering buying a car. you can see its full history of owners through a blockchain, and ownership to you is transferred through a smart contract. So you can sort of see the trend here. A lot of middle services that exist right now don't exist in this model. There's a lot more freedom of flow of information and less censorship, and the idea is hopefully it leads to better informed decisions and more innovations. These are only a few applications, and in reality, there's like uncountable ways that the technology can be used. But the decentralized ecosystem is just in its early days. It has grand visions and incredible goals, but it's only possible to make an open computational system that works for everybody if everybody takes part in it. You have to have a say on what's right and what's wrong, or how to build or govern these ecosystems, which laws arise, and which laws dictate what's okay and what's not. The technology is just the tip of the iceberg. The most important part is how it affects the people. Thank you. If you want to hear more, or if you want a reading list of things to follow up on, you can find me on Twitter at @antiroyalty. Thanks.